interestingly called the Remote Peering Jedi, a portal into the remote peering ecosystem. I'm not sure if it includes time travel. It might.
Not yet.
Not yet, okay.
We're working on it. Next slide.
Go ahead.
So thank you very much. I'll present our hackathon project on detecting and localizing remote peering interconnection at IXPs. So the motivation is that both researchers and operators have incentives to know who peer remotely at IXPs so that they can inform their peering decisions. And to do it, we tried to replicate a paper on remote peering that was presented a couple of years ago, and we tried to automate it over ripe atlas paths. So we take the already collected paths. We found those that cross an IXP by getting the prefixes of the IXPs from PeeringDB, and we calculate the RTT between the near end and the far end interfaces of the IXP. That's a bit noisy, but since Atlas has so many paths collected, a huge corpus of paths are available to parse, so we get a large number of samples that allow us to filter out noise. We take the bottom half 50% percentile of the RTTs, and then we take the median. If it is over 20 milliseconds, we say that it's definitely remote. Here are the results. We can see that about 60 to 75% of the RTTs are less than 10 milliseconds. We just checked 5 large exchanges for the hackathon, but we plan to extend it. And it's interesting, for instance, to observe NE2 Los Angeles, which has this bump much later than the other IXPs due to the trans-Pacific links. The remote peerings are about 12 to 18%, and then we have a gray area of RTTs between 10 and 20 milliseconds, for which I can talk at the end of the talk. To validate our results, we collected data from boxes inside the IXPs, and we checked if the RTTs they observe agree with our own observations, and in almost all the cases they agreed, so we can be fairly confident that our results in terms at least of RTT inference are correct. And we checked whether the peerings that are remote to the IXPs are used also to access large CDNs. And I was a bit surprised by this result because apparently they are used to access. We checked Cloudflare and Twitter. The reason is that although some remote peers are also very well interconnected in their local peering ecosystem, the CDNs are not present, so they have to go all the way to Amsterdam or Frankfurt. So this is maybe a pointer for the CDNs to try and be more supportive for the smaller IXPs. Some of the remote peers are very aggressive in remote peering, are the usual suspects. So we have some of them peering in all the IXPs that we checked. And that may have some implications on the actual multi-homing resilience versus on the other someone may observe if we check just the layer 3 presence. And also this work gives us some opportunities to interpret better the data that are recorded in PeeringDB voluntarily by the AESs, because many of these remote peers claim to have local presence in the IXPs that it turned out they are remote. Between 16% and 25% actually in PeeringDB record that they are located in a local facility, which is either wrong due to I don't know, fat finger errors, or because they want to appear more appealing, or because they have a different interpretation of the field, and they may not mean exactly physical tenancy, but the ability to have private interconnections there. So now the problem was not just to detect the remote peers, but also to find their location. And we started with some already available techniques, OpenIPMap and DNS-based geolocation, which are both accurate and simple. But the problem is that they cover just a subset of the IPs that we had in our data set. And then to fall back, we didn't want to go directly to geolocation databases which are widely inaccurate. So we we sort of created a new approach, which is we call the presence informed or peering DB informed RTT geolocation. And the idea here is to make the problem space smaller by taking the locations where the owner of the IP that we want to geolocate is present, and try to ping the IP from the Atlas probes in the same locations, and then just get the city with the lowest RTTs if these delays are lower than 10 milliseconds. And this methodology can be implemented exactly because Atlas has so many probes that the platform covers almost all major cities. So here are the results for a remote peer that we observed in Gigis. It's obviously, if you cross-check the RTTs in Riga, in Latvia. So it's this remote peer. In total, they had 10 cities in peering DB. We ran 5 pings from 5 probes in each city. And I think the results are telling. So we also have a demo where we show where and who is remote peer in some major IXPs. These are real data from RIPE Atlas paths last month. So we have the points in the map. Someone can easily see both the AS, the IP, and the location, and we also have the median RTT in case, let's say, a peering coordinator may be interested in the median RTTs and make decisions based on that. And if we change IXP, you can see that some of the pins remain in the map between the different IXPs, which indicates what I talked about earlier, the usual suspects who peer everywhere, basically remotely. And this is understandable, given often the distance from the main content providers. And here you can see for any two, for example, how the remote peerings are on the other side of the Pacific Ocean, so we had this much higher RTTs for these guys. So this is public. We plan to extend it with more IXPs and more data, and make also the raw data available, not just the map in case someone wants to download them and crash them. We are already working on extending the system, so we will try to keep you updated through mailing lists. And yeah, thank you very much. Also, just a point about the hackathon. It was a great experience. I really enjoyed it as well. So I'm planning to join next year if it's possible.
All right, thank you. Any questions or comments? Stunned silence again. I think that's a compliment. Phil, I thought it was very good. Thank you very much. I hope we see the continuation of this project. And by the way, that link is actually live and you can play around with it. It's pretty cool. Up next is Francisca, I think. She looks scared? No. And Francisca is going to talk about bad stuff at IXPs. You have a clicker? Yes, that's the one. This goes forward and that goes back.
Okay, thank you. Okay, hi, I'm Francisca. I work at TU Berlin.